So last week we talked about finding trig functions, trig values for angles on the unit circle where the unit circle has a radius of 1. So now we're actually going to talk about how we can find trig values and evaluate trig functions for angles that are not on the unit circle, where the circle has a radius other than 1. So let's take a look at this problem. You are asked to find all 6 trig values, so sine, cosine, tangent, cosecant, secant, and cotangent, for some angle theta, notice theta, given that the terminal side of the angle goes through a specific point, -8, -15. Okay, so notice you are not asked to find the size of theta. You are not asked to figure out how many degrees are in the angle. What we're asked is to figure out what is the sine of the angle and the cosine of the angle. And we can actually evaluate all 6 of those trig functions without even knowing how big the angle itself is. So you want to start by actually drawing a picture, all right? Anytime you're working with angles, whether they're on a unit circle or not, give yourself a visual to work with, because a lot of this is going to hinge on finding a triangle. So I know that the terminal side of the angle goes through -8, -15. We also know the initial side always sits right here. So anytime you're trying to draw an angle on a circle, you'll put the initial side on the positive x-axis. The terminal side goes through -8, -15, so that means I have to go back 8 and down 15 units. So let's say that's somewhere right about here. There's the terminal side. -8, -15. All right, well, think about what we just did. We just went back 8 units and down 15 units, okay? So let's draw ourselves a right triangle in this figure. And when you want to draw the right triangle, you're going to put in an altitude to the x-axis. I made a big deal about the x-axis in my videos last week. So you're going to draw an altitude to the x-axis. There's your 90-degree angle. And I know that this distance here is 8, and this distance here is 15, but notice that there's direction, right? We're going back 8, and we're going down 15 units, okay? Now there's your right triangle. From the origin to the point where the terminal side would hit some circle, not necessarily the unit circle in this case, but hit some larger circle, this would be the radius r, right? And we actually want to figure out, well, what is that distance? Well, this is a right triangle, and we know the Pythagorean theorem applies to right triangles, so let's do a squared plus b squared equals c squared. Where we've got a and b. We have both of the legs, but we're looking for the hypotenuse, which in this case would be the radius of our circle. Okay, so I would have -8 squared plus -15 squared equals c squared, my radius. I have 64 plus 225 equals c squared. 289 equals c squared. And when I take the square root of both sides, I'm going to get that c equals 17. Now here's the thing about the radius of the circle. Notice that both of these legs, there was sort of direction implied. We had to go back on the x-axis, we had to go down on the y-axis, -8, -15. When you're solving for the radius, or in this case the hypotenuse c, keep it positive. The radius of the circle is going to be 17. So if I were to draw a big circle into this diagram, it's not a unit circle because its radius isn't 1, but it is some circle that has a radius of 17. And a radius of a circle is a distance, so because of that, we're keeping it positive. All right, so I now know the radius of the circle. I have all 3 sides of that triangle. That means I can evaluate all 6 of the trig functions. I have everything I need. So we've got theta. Theta is this large reflex angle right here. Initial side, terminal side. Its reference angle is right in here. So its reference angle is that little acute angle that originates out from the center of the circle. So here's theta, but the reference angle sits between the terminal side and the x-axis. So you can think about this a couple different ways. You can pull this triangle off and apply SOHCAHTOA to it, or we can use what we know from last week's videos about the x-coordinate, the y-coordinate, and the radius of the circle, and how those things come together to find these 6 trig values. So for example, last week we covered that sine of theta is y over r, the y-coordinate over the radius. Okay, well you actually have the y-coordinate. The y-coordinate is negative 15, and the radius is 17. So if I put negative 15 over 17, that right there is the sine of theta. You could also think of that as, well, if I take this right triangle out of the diagram, I'm working with my reference angle here, this little acute angle. The opposite is negative 15, and the hypotenuse is 17. So you could also think about this as SOHCAHTOA. Cosine of theta, last week we covered that that's the x-coordinate over the radius. So in this case, it would be negative 8 over 17, radius of the circle. But you could also think of this as SOHCAHTOA, using your reference angle, that little acute angle in the right triangle. It would be the adjacent side, negative 8, over the hypotenuse of 17. Tangent is y over x. Y-coordinate over x-coordinate, so that's negative 15 over negative 8. And anytime you're dividing two negatives, they make a positive, so tangent would actually be 15 over 8. And so something to think about here is, all right, well, what quadrant are we in? We're in the third quadrant. I'm seeing sine is negative, cosine is negative, but tangent is positive. And that's the pattern that we should see. We established this last week, all right? All trig functions are positive when the terminal side is in quadrant 1. Sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. And that is all based on the way that the x and y coordinates come out to be positive or negative. All right, so now that we've got these first 3 trig values, let's find the other 3, the reciprocal trig values. Well, I know that cosecant is related to sine. All I have to do is flip those values and I'll have cosecant. So this would be 17 over negative 15. Secant is the reciprocal of cosine. So this would be 17 over negative 8. And finally, cotangent is the reciprocal of tangent. Flip, this would be 8 over 15. So we have our 6 trig values. And at no point do we actually have to figure out how big that red angle theta was, right? All I had to do was draw a picture of it, figure out what quadrant am I working in, what are the x, y coordinates, what's the radius of the circle that I have, in this case it turned out to be 17, and once you have x coordinate, y coordinate, and radius, we just apply what we learned last week about the trig functions and the reciprocal trig functions, and we can find all the trig values without ever knowing theta. So, that's your video.